When a star dies, an entire region of the universe may pay the price. Is Earth safe? Supernovae, the powerful explosions of massive stars, are not only spectacular cosmic events, but also pose significant risks to nearby civilizations. These explosions release immense amounts of energy that can profoundly affect life on planets within their vicinity. Supernovae, awe-inspiring and destructive events. Supernovae are among the most magnificent and intense phenomena in the universe, marking the end of a massive star's life when it exhausts its fuel. When the star can no longer sustain fusion reactions to counteract gravity, its core collapses in an instant, producing a massive explosion. This event not only obliterates the star, but also emits an enormous amount of energy, sufficient to illuminate an entire galaxy for a brief period. The energy released from a supernova includes gamma rays, X-rays, and shock waves, all traveling at extremely high speeds with destructive power. Gamma rays, the highest energy radiation, can travel hundreds of light years through space, breaking molecular bonds and causing severe damage to planetary atmospheres within the affected zone. Shock waves, propagating nearly at the speed of light, can significantly alter the spatial environment by displacing dust and gas, reshaping surrounding regions. Notably, supernovae are not solely destructive, but also serve as a source of cosmic regeneration. During the explosion, intense nuclear reactions produce heavy elements such as gold, silver, and uranium, essential components for planet formation and even life. When these elements are dispersed throughout space, they become seeds for the creation of new stars and planetary systems, playing a vital role in the universe's evolutionary cycle. However, supernovae also present substantial risks. A nearby supernova explosion could have severe impacts on surrounding planetary systems, including altering atmospheres or even threatening life on planets. This underscores the fact that in the vast universe, events occurring at seemingly distant locations can still lead to widespread and profound consequences. With their dazzling beauty and immense power, supernovae are a testament to the dynamic and ever-changing nature of the universe. They serve as reminders of the balance between destruction and creation within the vast expanse of space. Supernovae and their threats to civilizations. A supernova is not only a magnificent astronomical event, but also a harbinger of potentially catastrophic consequences for any civilization within its range of influence. With immense destructive power, a supernova can entirely transform the environmental conditions of nearby planets, particularly those hosting life. Gamma rays and X-rays emitted from a supernova explosion are among the highest energy radiation forms in the universe. These rays can destroy the ozone layer, a critical protective barrier in a planet's atmosphere. Without this shield, the planet's surface would be exposed to ultraviolet radiation from its parent star, leading to the deterioration of the biosphere. Increased UV radiation can damage the DNA of organisms, raising the risk of mass extinctions, especially for species dependent on environmental stability. Beyond radiation, the shock waves from a supernova pose severe threats. Traveling at nearly the speed of light, these waves carry immense energy, capable of stripping away a planet's atmosphere, vaporizing key gases like oxygen and nitrogen. Consequently, the planet would lose its natural protective layer and become uninhabitable. For advanced civilizations, such losses could disrupt or obliterate their survival structures, from natural ecosystems to artificial environments. Additionally, the influx of high-energy particles from a supernova can destabilize technological systems, particularly space-based infrastructure, such as satellites, communication networks, or energy grids. These impacts are not merely technical, but could lead to the collapse of essential infrastructure, paralyzing societal functions for extended periods. The effects of a supernova are not limited to immediate destruction, but leave long-term consequences. These outcomes can slow the evolution of life or set back the development of civilizations by millennia. This underscores that supernovae represent one of the harshest challenges any civilization in the universe must confront, highlighting the fragility of life against uncontrollable cosmic forces. Is Earth safe from supernovae? Although Earth is currently considered relatively safe from supernova explosions, risks remain if an event occurs within 50 to 100 light-years. Scientists have hypothesized that some major extinction events in Earth's history may be linked to the effects of nearby supernovae. One notable example is the Ordovician-Silurian extinction event, approximately 440 million years ago. Some scientists suggest that radiation from a nearby supernova destroyed Earth's ozone layer, leading to a sharp increase in ultraviolet radiation from the Sun. This resulted in a significant decline in marine organisms, which dominated at the time. If a similar explosion were to occur today, the consequences could be severe, ranging from irreversible climate and environmental changes to the collapse of ecosystems, placing humanity in a survival crisis. Beyond biological impacts, radiation from a supernova could disrupt modern technological systems. Electronics, communication satellites, and infrastructure reliant on technology would be highly vulnerable to high-energy radiation like gamma rays and X-rays. This disruption would not only interfere with daily life, but could also trigger a global crisis in economics, communication, and energy management. Currently, astronomers are closely monitoring massive stars near Earth, particularly Betelgeuse, a prime candidate for a future supernova. At approximately 642 light-years away, Betelgeuse lies outside the direct danger zone, but its explosion would serve as a stark reminder of the immense power of cosmic phenomena. Furthermore, scientists warn that continued observation and research are essential for stars closer to the critical threshold. However, studies of supernovae are not solely focused on predicting and mitigating risks, but also on unlocking opportunities to better understand the universe. These explosions provide crucial insights into the life cycles and evolution of stars, and help us learn more about how heavy elements, essential for life, are formed and dispersed throughout space. Thus, researching supernovae not only protects Earth, but also significantly contributes to expanding humanity's scientific knowledge and preparing us for the challenges posed by the universe in the future. Supernovae vividly illustrate the power and destructiveness of the cosmos. From creating heavy elements to threatening nearby civilizations, they remind us of the fragility of life and civilization within a vast and ever-changing universe. With advancements in science and technology, studying and monitoring supernovae not only aids in protecting Earth, but also opens new doors to understanding their role in the universe's evolution. What happens when two giant galaxies collide? Can humanity survive this grand event? In the ever-moving universe, collisions between galaxies are natural yet profoundly turbulent phenomena. Our Milky Way and Andromeda, the two giant galaxies, are on a path toward a monumental merger. This event will not only be a spectacular cosmic display, but also one capable of reshaping the entire systems of stars and planets within. The inevitable merger of the Milky Way and Andromeda. The Milky Way and Andromeda are heading toward an inevitable merger, as determined by astronomers. Andromeda, the largest and closest galaxy to the Milky Way, is moving toward us at a speed of 110 kilometers per second. Cosmic simulations predict that in approximately 4 billion years, the two galaxies will collide and merge, forming a massive new galaxy, often informally referred to as Milky Way. While the prospect of two galaxies colliding might sound alarming, an interesting fact is that most stars within the two galaxies will not directly collide. This is due to the vast distances between stars, significantly reducing the likelihood of direct impacts. Instead, the immense gravitational forces of the two galaxies will stretch and reshape the orbits of stars and planets, creating chaos in galactic structures while forming new orbital patterns. This merging process will not only alter orbits, but also trigger fascinating astronomical phenomena. When the massive gas and dust clouds from both galaxies collide, they will ignite waves of new star formation. Gas-rich regions will become cradles for young stars, breathing new life into the merged galaxy. This process will reshape the galaxy's overall structure, highlighting the dynamic beauty of the universe. The merger of the Milky Way and Andromeda is not just a spectacular astronomical display, but a powerful reminder of the universe's constant motion. The universe is not a static entity, but a dynamic space where galaxies, stars, and planets continuously reshape and restructure. Although this event is far in the future, it offers profound insights into the vibrant life cycle of galaxies, while raising larger questions about the ultimate fate of the universe we inhabit. The consequences of a galactic collision. When two massive galaxies like the Milky Way and Andromeda collide and merge, the universe will witness profound and complex consequences in both the original and newly formed galactic structures. One of the most noticeable impacts will be the dramatic changes in the orbits of stars and planets. The immense gravitational forces between the two galaxies will displace stars from their original positions, forcing them into new orbits or even ejecting them from the merged galaxy. These ejected stars could become rogue stars, drifting through intergalactic space. In addition to orbital restructuring, the massive gas and dust clouds from both galaxies will collide and combine, generating powerful shock waves. These shock waves will trigger large-scale star formation, bringing a new cycle of life to the merged galaxy. However, alongside star formation, this process will also increase the number of supernovae, high-energy astronomical events that emit intense radiation, potentially threatening planetary systems in proximity. Another significant consequence is the change in the center of the new galaxy. As the two galaxies merge, the supermassive black holes at the centers of the Milky Way and Andromeda will converge, forming an even larger black hole. This merger will not only reshape the galactic core, but also produce high-energy phenomena, such as X-ray emissions and strong gravitational waves, affecting the surrounding astronomical environment. While galactic collisions are a natural part of the universe's evolution, the consequences of this event will reshape the entire structure and environment of the new galaxy. These transformations could significantly impact civilizations in the region, particularly those near the core or affected by radiation and orbital changes. This is a testament to the dynamic and ever-changing nature of the universe and a reminder of the immense scale and power of astronomical processes. Risks and opportunities for civilizations. The collision between two galaxies, such as the Milky Way and Andromeda, is not only a majestic astronomical event, but also poses significant risks to any civilization within its sphere of influence. Civilizations near the collision's core will face extreme radiation from supernovae and high-energy phenomena related to the merger of supermassive black holes. These factors could severely damage planetary environments, including atmospheric destruction, increased ultraviolet radiation, and drastic ecological changes, pushing many species to the brink of extinction. Not only are regions near the galactic core affected, but more distant areas, such as the solar system's location, could also face indirect consequences. The immense gravitational forces from the galactic merger could alter the orbits of stars and planets, including the solar system. This could disrupt climatic stability or create gravitational disturbances with long-term effects on Earth's habitability. For advanced civilizations, the impacts of a galactic collision go beyond physical environments. The chaotic restructuring of the galaxy could create significant challenges for maintaining communication and navigation systems. Technologies reliant on radio signals or light-based communication may function poorly in environments dominated by radiation and high-energy phenomena. This could hinder civilizations from coordinating, exchanging information, or navigating space effectively. However, with adaptability and innovation, advanced civilizations might develop solutions to overcome these challenges. They could migrate to safer regions within the galaxy, or even develop advanced protective technologies to mitigate the effects of radiation and gravitational changes. Large-scale constructions such as energy shields or mobile space bases could become key to their survival and continued progress. While the dangers of a galactic collision are undeniable, this event also presents opportunities for civilizations to test their limits, develop new technologies, and expand their understanding of the universe. It is not only a crisis, but also a trial of survival and evolution in an ever-changing universe. Galactic collisions, such as the impending merger of the Milky Way and Andromeda, are astronomical phenomena, both spectacular and challenging. From the complete restructuring of stellar orbits to the risks of intense radiation and gravitational changes, this event has the potential to reshape not only the galaxy, but also the civilizations within it. While Earth may not directly face severe consequences, the journey to explore and understand galactic collisions will better prepare us for future challenges posed by the universe. What would happen if an invisible black hole approached Earth? Rogue black holes are among the most dangerous lurkers in the universe. Dark, silent, and drifting through galaxies. Although rare, if a rogue black hole were to approach a planetary system with life, it could unleash unimaginable disasters. This makes them one of the most fearsome potential threats to any civilization in the cosmos. The nature and threats of rogue black holes. Rogue black holes are unique cosmic entities that are not fixed in position but move freely through space. They often form after powerful cosmic events, such as high-intensity gravitational interactions or galaxy collisions. When two galaxies merge, the supermassive black holes at their centers can be ejected from their original locations by strong gravitational forces, turning them into wanderers traveling through the new galaxy. One of the biggest challenges in studying rogue black holes is their invisibility. They emit no light, making detection extraordinarily difficult. Unlike stars or planets, their presence is only revealed through their gravitational effects on nearby objects. For instance, if a rogue black hole passes through a star system, its immense gravity could disrupt the orbits of stars or planets, creating anomalies that scientists can observe. Rogue black holes vary significantly in size. They can range from stellar mass black holes, weighing only a few times the mass of the Sun, to supermassive black holes with masses millions or even billions of times greater than the Sun. Their size, combined with their velocity, determines the extent of their impact on the regions they traverse. Smaller black holes might quietly pass through space with minimal disruption, but supermassive black holes could cause major transformations in the structure of a galaxy or star system. Despite their stealth, rogue black holes harbor a terrifying destructive potential. If one were to approach a planetary system, its gravitational force could destabilize the orbits of planets, even pulling them into the black hole itself. This poses a real threat, not just to star systems but also to any civilizations living within their influence. To mitigate the risks posed by rogue black holes, scientists are developing advanced methods to track and detect them. Modern techniques, such as observing gravitational lensing effects or unusual optical phenomena, can help locate black holes even in the absence of emitted light. Nevertheless, rogue black holes remain one of the universe's greatest mysteries, sparking both curiosity and caution as humanity delves deeper into the vast cosmos. The devastating impacts on star systems. When a rogue black hole nears a star system, its effects are not only terrifying, but could also dismantle the entire structure of that system. The black hole's immense gravitational pull has the potential to destabilize the orbits of planets, pushing them out of their stable trajectories, which are crucial for maintaining climates conducive to life. For planets hosting life, such instability could lead to catastrophic consequences, such as significant surface temperature changes or the complete destruction of atmospheres, critical layers that shield planets from radiation and sustain life. If orbits are disrupted, a planet could be pushed farther away from its parent star, turning into a frozen world where water and air solidify. Conversely, if the planet is pulled closer to the star, it could become a scorched desert with extreme climates incapable of supporting life. In the worst-case scenario, the rogue black hole might directly consume planets or even nearby stars, leaving behind a dead zone of space with no hope of recovery. The effects of rogue black holes extend beyond orbital disruptions. As they move through space, they can generate gravitational waves, ripples in the fabric of space-time. These waves, though difficult to detect from Earth, can significantly affect nearby planetary systems. Gravitational waves may cause localized gravitational disturbances, leading to orbital instability or spacequakes. These disruptions not only impact planets, but can also weaken or destroy technological infrastructure belonging to nearby civilizations. For advanced civilizations, the presence of a rogue black hole in their vicinity poses an existential challenge. Technologies reliant on satellite systems, radio signals, or large space structures could be disrupted or destabilized by the black hole's gravitational pull and emitted gravitational waves. This could result in the loss of communication, data, or even control over critical systems. Additionally, environmental changes, from planetary climate shifts to increased radiation, could directly threaten their survival. To address this danger, advanced civilizations must develop observational and early warning technologies. Sensors capable of detecting rogue black holes from great distances could allow them to prepare countermeasures. Some civilizations might choose to construct planetary defense systems to mitigate gravitational or radiation effects. In extreme cases, relocating entire populations and resources to safer regions of the galaxy might become a necessity. However, the threat of rogue black holes is not only a challenge, but also an opportunity for civilizations to demonstrate their adaptability and ingenuity. Solutions developed to confront this phenomenon could lead to breakthroughs in technology, science, and understanding of the universe. More importantly, it could foster unity among cosmic communities as they face a shared danger. The implications for the solar system and humanity. Although the likelihood of a rogue black hole approaching the solar system is extremely low, if such a scenario were to occur, it could lead to unimaginable consequences, even the potential extinction of human civilization. The black hole's immense gravitational pull could destabilize the orbits of planets, including Earth. Once orbital stability is lost, chaotic climatic conditions could ensue, destroying fundamental elements necessary for life, such as stable temperatures and a protective atmosphere. In the worst-case scenario, Earth could be dragged out of the Sun's habitable zone, transforming into a frozen wasteland or a scorched world incapable of sustaining life. Even if a rogue black hole doesn't directly affect Earth, merely passing through the solar system could have serious repercussions. Its gravitational force could disrupt the orbits of planets, comets, and asteroids within the system. This instability could increase the likelihood of celestial collisions, triggering meteor showers or enabling large asteroids to approach Earth. Similarly, the asteroid belt between Mars and Jupiter could be significantly perturbed, releasing massive objects into the inner solar system and endangering planetary safety. To counter this risk, scientists worldwide are focusing on developing technologies to detect and monitor rogue black holes from a distance. One of the most advanced methods involves using gravitational telescopes, tools capable of detecting even the smallest space-time distortions caused by a black hole's gravity. Optical and infrared telescopes also play a crucial role, observing signs of rogue black holes through their interactions with surrounding matter, such as bent light or dust clouds being drawn toward them. Beyond detection, scientists are exploring preventive measures to protect Earth from the effects of rogue black holes. Strategies include monitoring the motion of objects within the solar system, predicting orbital disruptions in advance, and even developing technologies to relocate planets from danger zones if necessary. These challenges also present opportunities for humanity to advance its understanding and adaptation to cosmic threats. While the probability of this scenario remains low, studying and preparing for it is an essential task. These efforts not only safeguard life on Earth, but also drive scientific and technological progress, enabling a deeper understanding of complex astronomical phenomena. Preparation is also a way for humanity to affirm its readiness to face great challenges while seeking opportunities to survive and thrive in an ever-changing universe. Rogue black holes are one of the most terrifying yet least understood threats in the cosmos. From dragging planets out of their orbits and disrupting star systems to the potential annihilation of civilizations, they remind us that the universe is a constantly moving space filled with potential dangers. With scientific advancements, humanity is steadily approaching a better understanding of and preparation for these cosmic threats, ensuring the long-term survival of civilization on Earth. What would happen if a solar flare crippled all human technology? Solar storms, powerful eruptions of energy from our closest star, are not just fascinating astronomical phenomena, but also potential threats to modern civilization. These extreme events can cripple power grids, destroy satellites, and cause severe consequences for life on Earth. Understanding solar storms and their mechanisms. Solar storms are natural yet highly energetic and powerful phenomena generated by the complex magnetic activities on the surface of our central star. They occur when the Sun releases massive amounts of energy through solar flares and coronal mass ejections, CMEs. These events often originate from sunspots, regions of intense but unstable magnetic fields that lead to sudden and violent energy discharges. Solar flares are short but intense bursts of electromagnetic radiation, including X-rays and ultraviolet rays, traveling through space at the speed of light. In contrast, CMEs are large-scale ejections of plasma, charged particles, thrown from the Sun's outer atmosphere, corona. These particles travel at millions of kilometers per hour, creating powerful solar wind waves that spread across the solar system. When these particles interact with a planet's magnetic field and atmosphere, they can cause significant environmental changes, especially on planets without strong magnetospheric protection. The impact of a solar storm depends on the direction and intensity of the eruptions. When charged particles from CMEs reach Earth, they interact with the planet's magnetosphere, creating phenomena such as auroras, brilliant light displays at the poles. However, more powerful solar storms can have severe consequences. Electromagnetic radiation and solar winds can damage satellites, disrupt telecommunications and global positioning systems, GPS, and even cause power grid failures on the ground. In some cases, charged particles can pose health risks to astronauts working outside Earth's magnetosphere. History has recorded several solar storm events with significant impacts. One of the most famous is the Carrington event of 1859, a powerful solar storm that disrupted telegraph systems worldwide, causing fires at telegraph stations and illuminating the sky with auroras visible even in tropical regions. In the modern era, with increasing dependence on satellite technology and electronic systems, the risks posed by solar storms have become even more alarming. A similar event today could disrupt global communication networks and cause severe damage to economies reliant on technology. Studying and predicting solar storms is a crucial task in astronomy and space weather science. Space agencies like NASA and ESA currently use satellites such as SOHO and Parker Solar Probe to observe the Sun and monitor its activity. These data help predict the timing and intensity of solar storm events, providing early warnings for satellites, power grids, and other critical infrastructures. Solar storms are not only fascinating scientific phenomena, but also reminders of the immense power of the Sun in the solar system. Understanding their nature and impacts helps protect human civilization from potential disasters while opening new opportunities to explore the universe's powerful and mysterious forces. Impacts of solar storms on planets and ecosystems. Solar storms are not only highly energetic astronomical phenomena, but also pose significant threats to planets, especially those with ecosystems and living environments. When charged particles and intense radiation from the Sun reach a planet's atmosphere, they create profound effects, jeopardizing environmental stability and the civilizations developed there. One of the most concerning consequences of solar storms is the destruction of the ozone layer, a critical atmospheric shield. The ozone layer absorbs ultraviolet radiation from the Sun, protecting a planet's surface from its harmful effects. When charged particles from solar storms collide with the atmosphere, they can destroy ozone molecules, weakening or even eliminating this natural shield. As a result, the planet's surface becomes more vulnerable to intense ultraviolet radiation, which can cause severe impacts on ecosystems, including genetic mutations in organisms, reduced biodiversity, and even extinction of certain species. Solar storms can also destabilize a planet's atmosphere, causing space weather phenomena such as geomagnetic storms. These events occur when charged particles and radiation strongly interact with a planet's magnetic field, creating large-scale atmospheric disturbances. As a result, planets may experience unusual phenomena like dazzling auroras. However, simultaneously, electromagnetic systems such as satellites, GPS, and power grids may suffer severe disruptions or damage. For civilizations heavily reliant on technology, these disruptions could halt economic and social activities, potentially leading to widespread crises. Moreover, the intense interaction between solar storm radiation and atmospheric molecules can alter the chemical composition of the air, affecting its ability to sustain life. Ecosystems dependent on stable environments would suffer significant damage if the atmosphere lost its protective or regulatory capabilities. For example, sudden changes in climate or increased radiation could severely impact marine ecosystems, where organisms like phytoplankton, sensitive to ultraviolet light, play a crucial role in the food chain. Planets without strong magnetospheres, such as Mars, are particularly vulnerable to solar storms. Without magnetic protection, charged particles from solar storms can directly strike the surface, stripping away atmospheric molecules and gradually rendering the planet barren. This highlights the importance of preserving the atmosphere and magnetosphere for planets that support life. In summary, solar storms are astronomical phenomena capable of causing extensive impacts on planets. From ozone destruction and atmospheric destabilization to ecological and technological damage, their effects can push a planet from stability into chaos. Studying and predicting these events not only helps protect Earth, but also provides essential knowledge for addressing future cosmic threats. Extreme solar storms and human vulnerability. On Earth, extreme solar storms are not just potential threats, but real challenges humanity must face. The Carrington event of 1859 is a stark example of the severity of such storms. At that time, a massive solar storm disrupted telegraph systems globally, causing major fires at telegraph stations and producing vivid auroras visible even near the equator. However, in today's era of high technology, the consequences of a similar event could be far more catastrophic. One of the most significant impacts of solar storms is the destruction of satellites, the backbone of many modern technological systems. When charged particles from the sun interact with satellites, they can cause severe damage to electronic components, rendering satellites inoperative or permanently disabled. This would directly affect critical sectors, including telecommunications, GPS, weather forecasting, and even military operations. A widespread outage could paralyze global communication systems, disrupt air traffic, and severely impact economic and trade activities. In addition, Earth's power grids are among the most vulnerable targets during geomagnetic storms. Strong induced electric currents from the storms can overload transformers, leading to widespread power grid failures. In recent history, the Quebec blackout of 1989, caused by a solar storm, left millions of people without power for hours. A similar but larger-scale event, akin to the Carrington event, could result in global blackouts lasting months, crippling production and service industries. Furthermore, the global economy would face severe disruptions if an extreme solar storm occurred. Financial systems, heavily reliant on telecommunications and digital technology, could collapse, leading to the breakdown of business transactions. Industries such as transportation, energy, and healthcare would also encounter significant challenges due to interruptions in essential services. To mitigate these risks, scientists and engineers are developing early warning systems to predict solar storms. These systems use observations from space telescopes and satellites to monitor solar activity, providing warning times of several hours to days. This allows authorities to implement preventive measures, such as shutting down sensitive satellite systems, isolating transformers, or preparing emergency plans to handle widespread power outages. Protecting critical infrastructure such as satellites, power grids, and communication networks from solar storm impacts is an urgent task. Measures like strengthening the design of electronic components against radiation and developing backup energy sources are essential steps to ensure the stability and safety of human civilization. Although the probability of an extreme solar storm is low, its potential consequences are severe, requiring constant vigilance and preparedness to confront one of the greatest threats from the universe. Extreme solar storms exemplify the uncontrollable power of the cosmos and the fragility of human civilization. From disrupting modern technology to altering atmospheric environments, their impacts could upend life on Earth. However, with continuous scientific advancement, We are gradually acquiring the tools and methods to address these challenges, protecting civilization from the threats posed by the star we depend on.